Like I said, today we're doing the very last conic shape, which is a hyperbola. Now we add hyperbolas because hyperbolas are the most conceptually abstract conics that we go over. Now, as you can see, just like ellipses, there's a horizontal hyperbola and a vertical hyperbola. And let me just quickly read this definition for what a hyperbola is. It's the center point in a plane such that the difference, now that's the key word right there, difference of the distance between any, oh crap. All right. So here, what the heck was I saying? Where did I stop this? Okay, the difference of the distances between any point of the on the hyperbola and two fixed points in is constant. Now what this means is a hyperbola's equation is always going to be subtracting two terms. That's the difference between an ellipse and a hyperbola. Ellipse is adding the x value and the y value. Hyperbolas are subtracting x and y. It also says if the x term is positive, the parabola is horizontal. And if the y term is positive, the parabola is vertical. So just like an ellipse, we have a horizontal hyperbola and a vertical hyperbola. Now looking at these hyperbolas, there's just a few values that we need to define. If I'm looking at this horizontal hyperbola, what makes this a horizontal hyperbola is that the foci are on the horizontal axis, right? The left and right versions of the hyperbola, the parabolic shapes individually, are opening left and opening right. If it had been a vertical hyperbola, they would have been opening up and opening down. I also want you to notice that we no longer call the line that the center and foci go through, we don't call this the major axis anymore. We call this the transverse axis. Or, what is it, focus axis, I think they call it? Focal. Which this is annoying to me that they changed the name. I sometimes feel like mathematicians and scientists just change the names of things so that they can sound smarter. Like, ooh, instead of calling this the major axis, let's call this the transverse axis. That sounds more impressive. And instead of calling it the minor axis, they, for a hyperbola, call it the conjugate axis. They're the same thing though. The A value is on the transverse axis, and it is the length from the center to the vertex. The vertex being the like center points of your parabolic shapes. So here, this from the center to our vertex is our A value, which this on a hyperbola is now called the semi-transverse because it is half of the transverse axis. And the B value is just a little bit more tricky conceptually for hyperbola because notice it's not defined by a point created by the line of our hyperbola, right? It is actually created by a special hyperbolic box, all right? Now this box is actually created from the two asymptotes on a hyperbola. All hyperbolas have two asymptotes that are like diagonal lines between the two sides of the hyperbola, the two parabolic shapes. So what I'm gonna do right now, because the box is very important, I'm going to go ahead and draw in your asymptotes. The asymptotes go through the center and go along the sides, oops, of your parabolic lines. So we have one asymptote and we have two asymptotes. So if we were to draw, and what color should I do this in? Purple. If we were to draw a line that is perpendicular to our transverse axis, going through our vertex to our asymptotes, where this perpendicular line touches the asymptotes is the line that creates your B value. So you can see, ooh, I drew that crooked. I erased too much. Okay. That's better. So you can see that there is a hyperbolic box that determines our B length, our semi-conjugate. This B length is called our semi-conjugate because it's half of the conjugate axis. Semi-conjugate. So again, the B value doesn't necessarily really go to a point on your hyperbola. It goes to an abstract box, the edge of an abstract box created by your asymptotes and your vertices. Uh-oh. Just accidentally took out the tip of my pen. Okay. So I know this is a lot. This is a lot of information, and it'll make more sense, obviously, when we go to actually graph one of these hyperbolas. But notice in these two hyperbolas here, this left-hand hyperbola is horizontal because the x value is the positive term. And notice that our right-hand hyperbola is vertical because the y value is the positive. Also notice that the a squared is always underneath the positive term. Always underneath the positive term. Also, in all of these formulas, notice that there are, in a lot of them, two separate coordinate points. This is because the top coordinate point or the top line is always assuming that your center is 0, 0. So here our center is 0, 0. That means that the focal axis, that transverse axis, I want to zoom in, okay. Remember, another word for focal axis is that transverse, which remember, if we were dealing with an ellipse, this would be called the major axis. If our center is 0, 0, then our focal axis or transverse axis is y equals 0. If the center is not 0, 0, then we use this formula to find the transverse axis. If we're trying to find our foci and our center is 0, 0, we can use this coordinate point plus or minus c as the h value, comma 0. If our center is not 0, 0, then we use the bottom coordinate point. So they just define two separate formulas based on whether or not your center is 0, 0, or if it's a different point. Same thing with the vertical. They define two separate points based on whether or not your center is at 0, 0. Again, I don't ever even look at this formula chart because most of graphing can be done just by logicking your way through the graph. But the only thing that I look at this for is for asymptotes, because I just cannot remember how to find the equation for the asymptotes. So I do look at this for these asymptotic formulas, asymptotic formulas. Also, notice that when we're trying to find the foci, we still need to know what C is, what that C value is. The C value can be found for a hyperbola by square rooting, this time a squared plus b squared. So remember, for an ellipse, we found the C value by subtracting. This time, we're adding a squared plus b squared. So I know I just threw a ton of info at you, and I know you're probably confused. It's fine. Probably 75 to 90% of you are confused, so you're not alone. I always like to look at the application before I can truly understand what's happening. I don't know if you guys are the same. Okay, definitely, right? I definitely need to see some sort of example first. All right, so let's go ahead and try to graph this. Now, a lot of this works the exact same way that an ellipse did. The h and k are still determined by what is added or subtracted from your x and y. So, what is our h value here? What is our h value? Yes, remember, the h is the opposite of whatever is added or subtracted from your x. So here, our h value is a -2. What about our k? What's our k value? Yes, meaning our center is located at -2, 5. -2, 5. That's our center is right there. Now, is this a horizontal hyperbola or a vertical hyperbola? Horizontal, yes. It is horizontal because your x term is the positive term. So this is horizontal. And which one, I'm trying to solve for A, which one determines my A value? The 9 or the 7? Oh, sorry, you guys answered. I totally was spacing out. Yeah, the 9 determines our A value, meaning our A is equal to what? 3. Good. The square root of 9 is 3. And B, therefore, is determined by the 7. So B squared is equal to 7. So what is our B value? Yes, square root of 7. So now I'm just going to use that A value to graph my vertices. This is a horizontal hyperbola, meaning that I'm going to count 3 left and right to draw my vertices. So from my center, I'm going to go 3 to the left. Oh, let me use pink. I'm going to go 3 to the left and 3 to the right. And these are my 2 vertices. 1, 5, and what is that? -5? 1, 2, 3, 4, -5, 5, yes. And remember, my B value is tricky on a hyperbola because it's not technically a point on my hyperbola. What it does is it creates the top and bottom edges of my box that's created for a hyperbola. So what I'm going to do here, I know that the square root of 7 is really close to 2.65. So from my vertex, I'm going to go up a little bit over 2.5. I'm not going to put a point. What I'm going to do is I'm going to draw a line there because I know that that's going to determine the top line of my box. And I'm going to go a little over 2.5 down from my center. And then I'm just, because I know I'm going to have to help me draw this, I'm going to finish drawing my box. So my co-vertices that are not actually points on my graph are located at the x value of -2 both times, but the y value of your center point plus your b value and your center point minus your b value. The reason I write it this way is because otherwise it'd be a decimal, and we really want to keep everything in simplest radical form. So that's why we write it like this. Okay. So the reason why we draw our box is because the corners of our box tell us where to draw our Isaac, I think you're unmuted. It's okay. Okay. So the corners of our box determine our asymptotes. And again, the reason why our asymptotes are so important is because the asymptotes shape the outer curves of our hyperbola. So when I'm going to draw this hyperbola, you really want to start with, of course, we draw the center and the vertices, but the next step is to draw our asymptotes because they shape our curves. So I'm going to go ahead and draw my asymptotes. The asymptotes go through the corners and through the center. So I have one, I have one asymptote going through the corners, through the centers, and the other asymptote going through the corners of my box, through the center. Like so. And then I can go ahead and actually draw my hyperbola by going through my vertices and approaching my asymptotes like this. Ugh. I can't draw. I wish I could like turn this. Oh, I can turn my whole thing. There we go. So I, for some reason, can't draw a curve to the side well. Apparently I can't draw it up and down well either. Well, that just looks like an absolute value. It's better. All right. So now what? Ooh, the foci. Foci, right? Foci. How or what do we need to solve for to find our foci? C, yes, which remember C is different for hyperbola we're no longer subtracting A and B, we're adding them inside of our square root. So my A is 3, 3 squared is 9. My B is square root of 7, square root of 7 squared is 7. 9 plus 7 is 16, which, happily enough for us, is a whole number. Now, if I'm remembering that my foci are on the same line as my vertices and center, maybe I shouldn't draw that dotted. I've got so many, well, it's fine. It's on that same transverse line, meaning, are my H values going to remain the same, or are my K values going to remain the same here as the center? Yes, your K value along that line is a constant 5. So both the foci are going to have a K value of, whoops, what was I about to write there? Who knows? A K value of 5. Our X value of the foci is determined by taking our H and both adding 4, the C value, and subtracting 4. So -2, and if you think that you're going to forget how we did this, you can write it right above. You take your H and you add 4, and you take your H and you subtract 4. So -2 plus 4 is 2. -2 minus 4 is -6. And I'll just go ahead and plot those. There are our foci. And semi-transverse, remember, is our A value. Semi-conjugate is our B value. And now the equation for our asymptotes. So this is the only thing that I maybe need this formula to help me with. Our center is not at 0, 0, and this is a horizontal hyperbola, so I am looking at this equation right here. My asymptotes are located at y equals plus or minus the b over the a times x minus h plus k. So all I'm doing is plugging in values to get my equation for the asymptote. Y equals plus or minus b, which is square root of 7, over a, which is 3, times x minus h, which h is a -2, so this becomes plus 2, and then plus the k. Any questions on graphing this hyperbola? Okay, cool. All right, so let's do the next one, which I can immediately see is going to be easier. Why is this one easier? Yes, there is no value subtracted from x or added from x, and there is no value added or subtracted from y, meaning your h is 0, your k is 0, you are centered at 0, 0. Now, the way that this hyperbola is written is slightly confusing based on the equations we saw on the previous page. So what I'm going to do is I'm just going to put the subtraction, the negative term, as the second term. So now, Is this a horizontal or vertical hyperbola? Did I say vertical? Yes, vertical. Good. It's vertical because your y term is the positive term this time. And which one determines our A, the 9 or the 16? The 9. The 9. It's no longer, oh, the bigger number is the A. That's no longer the truth. That's what an ellipse, that's how an ellipse worked. A hyperbola, the A value is always under the positive term. So here, A squared is equal to 9, meaning our A value is 3. It's always under positive term. And then, therefore, the B value is the other one. So this time our B is 4. So let's go ahead and graph these. Remember, your A determines your vertices. This is a vertical hyperbola, meaning that my vertices are going to be up and down from my center. So I'm going to go up 3 to get one of my vertices. Oh, let's not do pink. Let's do green to match the A. Up 3 and down 3. So my vertices are located at 0, 3, 0, -3. The other edges of my box are created by my B values. So I'm going to go left and right 4, 4, 1, 2, 3, 4. And I'm just going to right now finish drawing my box. That helps me to draw my asymptotes. Meaning my covertices are located at -4, 0, and 4, 0. And I'm just going to go ahead and finish drawing my, asymptotes going through the corners and through the center. Which these lines, I mean, hopefully you guys remember how to find equations of lines, linear lines. These lines, I probably don't need to look at that formula for, right? Our center, our y-intercept is 0, and our next perfect point from the center is up 3 over 4. So our slope is 3 over 4, and for one of the asymptotes, and the other asymptote is up 3, and then in the negative direction 4. So our asymptotes are located at plus or minus 3/4 x. Because there is no y-intercept, there's no plus or minus, it's just 0 there. But again, if this is too much thinking for you, like too much logic, go ahead and look at the formula, it's fine. And then because I have my asymptotes, I'm going to go ahead and finish drawing my actual hyperbola, going through my vertices and approaching the asymptotes, through my vertice, approaching the asymptotes. And remember, to find your foci, you have to know where your C or what your C value is. So here, C is the square root of A squared plus B squared. Our A is 3, so 3 squared is 9. Our B is 4, 4 squared is 16. 9 plus 16 is 25. So again, nice. Our C value is 5. Now, am I going to add or subtract this 5 from the H or the K value? I'm going to add or subtract 5 from H or K here. Yes, the K, right? This transverse is along the y-axis, meaning no matter what, our H value is 0, And the k value, we both add 5 and subtract 5. So my foci are at a positive 5 and also a negative 5. The farther out your foci go from the center, the wider your hyperbola becomes. And the semi-transverse is our A value, the semi-conjugate is our B. And we could have found the equation for our asymptote by looking at this formula. A plus or minus A over B times X. Our A was 3, our B was 4 times X. Any questions on the vertical hyperbola? Okay. So now we're gonna, what do I want to do first? Do I want to do, let's do the complete the square first. And we're just going to do number 4. And then we'll go on to do the one word problem I wanted to get to. So to complete the square for hyperbola behaves in the exact same way that completing the square for an ellipse did. First things first, we have to group the x's, group the y's, and we also have to pull the a value out of both of these separate quadratics. So I see here that my x squared has a negative 4 on it, meaning I am going to pull the negative 4 out of my x squared. I'm also going to pull it out of my other x term, which is a positive 8x. So positive 8x divided by negative 4 is a negative 2x. And I'm going to leave a space to complete my square. And I'm going to group together my y values, which my y values do not have an a term, so I don't need to worry about pulling an a value out of my y's. I just write them down, leaving a space to complete my square. And my constant needs to be moved to the other side by adding 4. Hopefully all of this is ringing true from last class. Hopefully you remember this. Now, how or what value do I add into my x quadratic so that it can be factored into a perfect square? Right, yes, exactly. We take our b value, which is negative 2, divide it by 2, it becomes negative 1, and we square it, we get plus 1. Now, whatever I do to one side of an equation, I must also do to the other. Am I just going to add 1 to my right-hand side? No, what am I going to do? Right, you need to multiply the 1 times the negative 4. So we have negative 4 times 1 is what we're adding in here. Then, same process for finding the value added into the y. We take our b value, which is negative 4, we divide it by 2, and we get negative 2, and we square it, and we get 4. And this y, the y quadratic, doesn't have an a value, so I go ahead and just add 4 here. So this right-hand side simplifies down to 4. And how do I finish completing the square for my x values? Oh, I should do this. Let's do this. How do I finish completing the square here? Okay, you guys are, yeah, you're like done with today. Yeah, you just take your b value and divide it by 2 and put it after an x. So negative 2 divided by 2 is negative 1. And it is this binomial squared to complete the x quadratic. Same thing for the y. You take your b value, which is negative 4, divide by 2, and you get negative 2, and put it after a y and square that binomial. And we have successfully completed the square for both the x and the y. But this is not yet a hyperbola. What is the last step we do here? Just like we did with ellipses, what do we have to do? Yes, we have to get the right-hand side equal to 1. So we divide everything by 4. So this becomes, oh, what is happening? Oh, my key was wrong. So this is y minus 2 squared over 4, but then here the 4's cancel, leaving us with just x minus 1 squared. That is negative. Meaning our a value is 2. Well, here, we'll finish it all up. Our center is at 2, 1. Our a value is 2, and our b value is 1. You can write it like this, or you can flip it so that the negative is in the middle. It really doesn't matter. Any questions on completing this square? I honestly, actually, I'm going to erase that. I want to, if I was you, I would want to flip it. Just because it makes finding the center in A and B easier. But it's up to your preference. Any questions? Okay. So now I do at least want to start these last page of word problems here. I don't even think that I am going to, even on the word problem day, do this second hyperbola problem because it's very, very tricky, and I don't think that I don't even think your homework goes over it, so why would I put you through that torture? But we're definitely going to do this top portion. So it says that now this is a misprint, this is transverse. The transverse axis has endpoints of -2, -1, and 8, -1, and a conjugate axis with a length of 8. Find the equation. Now, every ellipse and hyperbola have 3 major components. The center, the semi-transverse, which remember is our a value, and the semi-conjugate, which is our b value. Right? Because we always have an x or y term over the a term squared minus x or y term squared over the b term squared. Is that equal to 1? So we need to figure out these values. Who knows how we can find the center? Yes. Exactly, Samantha. Yes. They give us the endpoints of the transverse. So all we have to do to find the center is know the average between those 2 points, the midpoint between those 2 endpoints. So the center is equal to the midpoint, which is equal to, now either you can just average the 2 points together by adding them together and dividing by 2, or you can remember the midpoint formula, which has you take the x values, add them together, and divide by 2. Take the y values, add them together, and divide by 2. So our center is located at -2 plus 8 is 6 divided by 2. That's 3, comma. Our b value, or k value of our center is located at -1 minus -1, which is -2, divided by 2 is a -1. So our h value is 3, our k value is -1, meaning in our equation, I'm going to write down -3 and a +1. Now, we are going to find the semi-transverse and semi-conjugate, but let me ask you this first. Is this a horizontal hyperbola or is it a vertical hyperbola? It is horizontal. Do you know why? Or how did you figure that out? Yes. So what you're looking at here is these endpoints, right? You recognize that the endpoints have the same y value or the same k value. This means that your vertices are on this horizontal line. Our transverse is horizontal, making this a horizontal, meaning that our x is the positive and our y is the negative. This is torture for me because our time is almost up and I really need to go to the restroom. Okay, so let's do the easy one first. How do you find your semi-conjugate? And please just answer quickly because I really need to go to the restroom and we want to finish on time. So how do you find the semi-conjugate? Oh, God. So remember, the semi-conjugate, right? The semi-conjugate is our b value, and semi means half of the conjugate. How long does it say the conjugate is? Yep. So then what's the semi-conjugate? Divide by 2, it's 4. Half of the conjugate is 4. What about the semi-transverse? This is a little bit harder one. How can we figure out how long our transverse is? It gives us the endpoints of the transverse, right? So if this is -2, -1, and this is 8, -1. How can we know how far apart those are? Right. It's the distance from -2 to 8, which is how long? Yes, Samantha, yes, it's 10 long, but we're looking for the semi-transverse, So we divide that number by 2, meaning our A is 5. And remember, the A goes under the positive, so 5 squared is what is under our X value. And the semi-conjugate goes under the negative, so 4 squared is 16. And we have found this equation. All right, I'm not going to keep you longer. I do also want to go to, or I am going to go over part B, but I'm going to pause this and go to the restroom, and I'm going to let you guys go. And you can most likely figure this out on your own, but if you can't figure it out on your own, you can go ahead and watch the video that I'll post. Any last questions? All right, so now for part B. It says that the foci are at 0 plus or minus 3, and the transverse axis length is 4. Find the equation. Now, if you remember, to identify the foci, we always add or subtract C from either the H or the K, depending on if it is vertical or horizontal. Now notice the value being added or subtracted here is 3, meaning that the C must be equivalent to 3. And notice it's not being added or subtracted from anything. So that means that from our center, our K value must be 0. Otherwise, there would have been a number here in front of the plus or minus. This means that the center for this problem is 0, 0. And it tells us the transverse is a length of 4, meaning our semi-transverse, or half of our transverse, is 2. That's our A value. And then, now this is the tricky part. We're given our C value, and we know our A value. What we're trying to find is our B value. The only way to do this is the same way that we solve for C. We use that Pythagorean identity that states C squared is equal to A squared plus B squared. It's the only difference is this time, oh my gosh, we know the C. The C is 3, and the A is 2. So now we're trying to solve for B. 3 squared is 9, 2 squared is 4. We're going to have to subtract the 4 over to get the B by itself. Whoops, I put an equal sign there. I meant to put a plus. So 5 is what B squared is equal to, meaning B is equal to the square root of 5. So we know our center, we know our semi-transverse, our A, and we know our B. Now the question is, okay, is this a horizontal or a vertical hyperbola? If we look, our foci, which are on our transverse, are added and subtracted the 3 from the K value, meaning that no matter what, our H value is 0 for that transverse. So our transverse is vertical, and our foci are points on that vertical line. So this is a vertical, meaning our our X value is the term that is negative, and our Y is the term that is positive. Our A value squared is always under our positive term, so the 4 is under the Y, and the B value squared is under our negative, so the square root of 5 squared is 5, and it's set equal to 1. And we're done. That's our equation.